Hello guys, let's solve this integral right here. But according to the title, I'll ask you a question. Did you in fact solve this within 30 seconds? Well, I don't think so. If you did, well, you're amazing. You're talented at math. Because, damn, this may seem easy, and it's not that easy. And I've also given you guys some hints if you want to solve this on your own. Frac sub. So simply, first do partial fraction and then do u substitution or any substitution, but you kind of don't have to, and I'll show you later. So first, 1 plus x cubed, this just write it on its, let's just factorize it. So it's just like 1 cube plus x cube, which is a cube plus b cube, simply 1 plus x, 1 minus or a square minus ab, which is just x, plus b square, which is x square. And now we do partial fraction. So simply let's just do the partial fraction of within the integral first. I'm going to write the x square in at the front. This is equals to 1 plus x square plus x minus 1. Now this is a linear equation, so the numerator will be a constant or just a number. This is a quadratic equation, so the above will be a linear equation, and we'll have to figure out a, b and c. Now to figure out just this part, it's easy. I'll use the cover up method. So first cover up the factor of this, so 1 plus x, and ask yourself how that would be 0. So for this to be 0, x has to be minus 1. So, and look at the remaining. You'll have minus 1 by minus 1 square, which is 1, plus minus 1, minus and plus, right. So it will be 1 minus minus 1, which is 2, plus 1, which is 3. So we'll get that a is equals to minus 1 by 3. Now what about for this? Do we use the cover up method? Well, no. Because x square minus x plus 1, it doesn't have that any nice, or I don't think even real answers for this, like nice ones. So in fact we'll just have to use and test some nice numbers for ourselves. So first, let x equals to 0. Generally, if you just have a linear equation remaining and you want to just find out the constant for the linear term in the numerator, and let's say you've already found a or some other numbers, right? Just you know the other numbers except for this part, then usually in 90% cases you have to let x equals to 0 such that b will get eliminated because b times 0 is 0, and you'll just have c remaining, which you can figure that out. So when x equals to 0, so look at the left hand side. This easy whole thing will be 0 equals to, we know that's minus 1 by 3. 1 plus 0 is 1. So we'll just have minus 1 by 3 plus, as I said earlier, this will be 0. So we'll just have c. So we'll have 0, 0, minus 1. So, damn, x square minus x plus 1. Sorry. So we'll just have 1 above, 1 below. So that's just c. So simply we get c is equals to 1 by 3. Now to solve for b, let's just use let x equals to 1. So here when we let x equals to 1, this will be 1, this will be 1 plus 1, 2. 2 into 1 square minus 1, which is 0 in plus 1. So overall this is just 1 by 2 equals to a minus 1 by 3 by 1 plus 1, which is 2. So this is minus 1 by 6, but actually I'll just write 2 into 3 plus bx, so we have to find b into 1, so plus 1 by 3 by 1 minus 1 plus 1, so this is just 1, So in fact this is just plus 1 by 3. And now we'll just have to do some math. So this just multiply everything by 2 like this. 2 cancels, 1, and I think b should be 2 by 3, because 2 by 3 plus 3 3 minus 1 by 6. Ooh, let's just do the math. So this is 1 equals to minus 1 by 3 plus 2b plus 2 by 3. This will be 1 by 3 minus 1 by 3, 2 by 3, and then 2 2. So b equals to 1 by 3. Oh sorry, yeah, b is equals to 1 by 3, because 2 by 3, 2 by 3, 4 by 3 minus 1 by 3, which is 3 by 3, which is 1. Yeah, b equals to 1 by 3. Now we figured out our a, b, c, and we figured out what's inside this. So this is just equals to that. And another interesting part, you can see we have 1 by 3, 1 by 3, 1 by 3 in all of them. So just take that common. So first you will have minus 1 remaining by 1 plus x plus 1 by 3 we took, so just x. 1 by 3 also we have taken, so 1 x square minus x plus 1 dx. Now we can do this part over here, that's fine. Let's talk about that part. Now for this part over here, for the bottom part, let's complete the square, because or you can just do u substitution and get du, because here x square will give 2x minus 1, and you can kind of introduce that to the numerator by dividing by 2, multiplying by 2, and then adding and subtracting the constants to get our substitution in the u dimension, and then take the constant outside. But for easiness, let's just complete the square. So x square minus x plus 1. To complete the square, we need a square minus 2ab plus b square. So we have x square minus 2 into a into, well, our b can't be this, because here we just want x. So that means we have to divide by 2. And now this is our b. So we have to add by b square, which is just 4. And since we added by 1 by 4, we have to subtract by 4. Don't forget the plus 1. So this is just x minus 1 by 2 whole square, right? This is just 1 by 2 whole square minus 1 by 4 plus 1, which is just plus 3 by 4. But 3 by 4 we can, let's just write it in square root form. Square root of 2 by, so square root of 3 by 2 whole square. Now we have this below. Like so. Now what we can do is, well, we can simply let u equals to this part. That's where substitution comes. So u equals to x minus 1 by 2, and here we want to find x, or simply x plus 1 if we can. And but first let's differentiate it. Obviously du will equals to dx. Here x will be equals to u plus a half. Now let's just directly find plus x plus 1. So add 1 to the both side, meaning u plus 1 by 2 plus 1. 1 by 2 plus 1 is simply 3 by 2. So this integral is 1 by 3 minus 1 by 1 plus x plus u plus 3 by 2 by u square plus root 3 by 2 whole square du. And now again, well, since this is du, now let's just separate these integrals, dx, and then just bracket outside. And now we'll just have to solve for this integral right here, because this one just log natural. So let's just solve this integral, only this one, because let's just not rewrite it over and over again. So here we have to separate the numerator u and this part plus the constant and that part. So this is u by u square plus root 3 by 2 whole square du plus 3 by 2, let's put outside. So remaining just du by u square plus root 3 by 2 whole square. Now for this one, let's do another substitution but kind of in our head. So if we let w equals to the bottom part, this whole thing, when you differentiate it, dw will be equals to 2u du. But here we just have u, so simply let's introduce 2 and divide by 2. So this is just 1 by 2, it will be dw by w, which is just log natural of w, which is, well, that. So just the bottom part. Now we can use the parentheses for this log natural because we know u square will always be positive, and this positive of course, plus 3 by 2, and now this is just the tangent. The tangent case for this one, we have done it, the proof for this also. So if you have dx by x square plus a square, this is equals to 1 by a tangent inverse of x by a plus c. But in fact we're solving only this part, so let's just not write plus c for that because we have to compute the whole question actually. So this is into 1 by a, which is our square root of 3 by 2. So 1 by square root of 3 by 2, the 2 just goes above, so this is 2 by square root of 3. Tangent inverse of, well, by is below again, so this is 2 square root of 3. So 2u square root of 3, like so. And now let's just, in fact, you know what, let's just put u back into, well, x. So this will be 1 by 2 log natural of u square plus root 3 by 2 whole square. Now instead of just substituting u back into x and doing it all over again, let's see why we substituted u in the first place. We substituted u so that we can get that. That means this came from that, right? That's just reverse substitution. And this came from that. So in fact this and that are the exact same. So this is just a log natural of x square minus x plus 1 plus 3, 2 to cancel, root 3 you can also cancel that. So this is root 3 tangent inverse of 2u, which is 2x, 2 just multiply 2 on both sides, you'll get 2x minus 1, 2x minus 1 by root 3. Now we just have to put this in here. So this is 1 by 3, and at the same time we can just open the bracket as well. So this is 1 by 3 into the minus log natural. So minus log natural of 1 plus x. I'm going to use modulus because we don't know if x is positive or not. Plus 1 by 2 log natural of x square minus x plus 1 plus root 3 tangent inverse 2x minus 1 by root 3 plus c. And that is our final answer. So the integral x by 1 plus x cube is this. That's one crazy answer for such a simple looking question. So I mean, if you did this in under 30 seconds, well job. You're talented at math. You can try one of the 6 millennial problems and earn yourself $1 or even $2 million. So this is it, and if you learned something new, please like and subscribe. Thank you.